This video is a demo for EE542 Lab 2 socket programming. So to begin this lab, we'll have to create a topology with two nodes where one node runs the client program and the second node runs the server program. So to design this topology, we'll use this NS file where two nodes are defined and a LAN connection between them is also defined, and Ubuntu 16.04 is loaded into these nodes. So once this NS file is uploaded and an experiment is created, we get a topology similar to this. So now we can run the client program on node A and the server program on node B. So to do this, first SSH into deterlab using your username and password. Now you're in. Now I have already transferred the server.c and the client.c into my home directory using SCP. So you can see this. Now you can SSH into node A by using the qualified name of node A, which can be found here. You can SSH into node A. Now you can verify if the codes are also present in node A. You can create a new terminal where you SSH into node B. So SSH into node B and verify if the codes are present here. So now you can run the server program in node B, compile the program. Now the server program is running. Now the client program is compiled in node A. Now the server program is run in node B using this, and a random port number is given. Now the server program is running on node B. Now to run the client program in node A, we need the host name of node B. So to get the host name of node B, you type in host name. This host name is same as the qualified name of node B. So run the server program again. Now with the host name of node B, you can run the client program in node A. So copy this. Port number should be same as the port number given in the server program. Now you can enter the message that is passed to the server. Now you can verify that the server got the message as it replied back. You can also go into the server running in node B and verify that message was received. So this is how a client server communication is done using sockets. Next part of this lab is to incorporate enhancements into the server code. So this pseudocode incorporates the enhancement. What this code does is it enables the server to accept simultaneous multiple clients. So we can incorporate this pseudocode into the main code by adding this here. So what this code does is it forks off a child process for each client. So each client runs this part of the program and runs the toStub function, which then reads and writes into the socket. So once this code is done, we can change the NS file by adding an extra node. So in this case, we modify the NS file and we add an extra node C, and we include it in the LAN, and we also make Ubuntu run on this node. So now once this NS file is modified, the topology will look something similar to this. So this will be the topology. And now once this is done, we can run two simultaneous clients on two of these nodes and a server will run on the other node. So before doing that, we'll have to SCP the enhanced server program into the uh, deterlab account. So to do this, we can SCP the source path and the destination path. So once this enhanced server code is sent into deterlab account, we can SSH into the servers. I have already accessed node A and node B. So the only node remaining is node C. So to SSH into node C, get the qualified name of node C from details and SSH into this node. So the qualified name of node C is SSH node C. So now, since you have all three nodes, you can run the client program in node A and node B and the enhanced server program in node C. I have already compiled the client program in node A and node B. So now to get the host name of node C, type in the hostname command, and this is the host name of node C which runs the server program. So now to compile the enhanced server program. Once this is done, we can run the server program in node C by putting in a random port number. Now the server program is running. So now to run the client programs in node A and node B, type in the host name of node C, that is the qualified name. Just copy it from here and give the port number same as that of the server. Similarly, to run the client program in node B as well, now we see that the server has accepted connections from both these clients. So now go ahead and type in a message. You get a reply from the server acknowledging the message. Do the same thing in node B. We get the acknowledgement from the server. You can also go into the server and check if it received messages from multiple clients. So by adding that part of the pseudocode, we enabled multiple clients to be connected to the server. System has another problem called the zombie problem. The zombie problem arises when there are a lot of zombie processors left behind from dead children. When a parent forks off child processes and when the child processes die, they do not get completely wiped off. The parent process waits to get the exit status of the children and thus creating lots of zombie processes. To check the presence of these zombie processes, I have logged into node C, which was acting as the server, and node A and node B were acting as a client. Once node A and node B finished sending a message and they were killed, we see the presence of these zombie processes by the Z plus of the two clients. So this this shows the presence of the zombie problem. In order to prevent this, we have to tweak the server code a little. So to do that, we go into the server code. This is the enhanced server code. So in order to prevent the zombie problem, we add this signal sig child sig ignore in the enhanced server code. and we add the signal header file. What this signal does is it ignores the child signal that is sent by every child to the parent when it is killed. So, so in this case, the parent does not wait for the child to die, and the exit status is sent automatically to the parent. So once this enhancement is done, we'll have to copy the files back into the deterlab folder. So to do that, we SCP the file to the user's .deterlab.net account. So put in the source path and the destination, which is the users.deterlab.net folder. Now we repeat the same steps by running the client processes in two nodes A and B and running the server in node C. So we'll first SSH into these nodes. So now I have SSH into the nodes. Now we'll have to run the client processes in node A and node B. So we go ahead and compile the client program in node B as well. So when we compile the server program in node C, now we run the server program in node C. And we run the client program in node A. We do the same thing in node B. Type in a message from node B and node A. Now we check for the presence of zombie processes. To do that, we type in uh, PSAUX and we grep for Z. Now we see that there are no zombie processes present. So by adding in the signal, uh, by ignoring those sick child signal that is sent by the clients, we prevent the zombies from clogging the. We prevent the zombie processes staying in the system. So this completes Lab 2 socket programming. Thank you.